Hello everyone. So here is a machine learning operations assignment for bits planning, and the requirement is we have to design, develop, and deploy a scalable, reproducible machine learning solution using MLOps best practices. And our data set is a UCI machine learning repository where it contains 14 plus features and a binary target, whether the heart disease is present or not. So this is our problem statement, and these are the some assigned tasks. So based on these tasks, I have prepared my assignment. So here it is. So let me walk through these solutions right now. So we have this artifact. So this is virtual environment. Let me delete it again. So we'll create from the starting again. Let's delete this virtual environment once. Okay. This is artifacts where our artifacts for logistic regression, the random forest, both will be saved here. And then data, where we contain the raw data, this and the process data. Then Docker, compose YAML, Docker file, then some documents like architecture, the final report, README, setup. This setup, we'll use this setup file to showcase you demo. So we'll go through this one once. This is our Kubernetes deployment YAML. AIML runs models, and then models it contains the .job library lib and rest Georgia library. So logistic regression, the random forest, both job lib format here, and this is monitoring. So we are using Prometheus YAML for that one. Some screenshots for our final report submission. We'll use those screenshots to attach in final reports. Then SRC, this is our means solution where we contains the model preparation, pre-processing, all those stuff we are keeping it here. This is test, API data and the model test, and some readme requirements. What are the requirements to run this project? This setup API. So we'll let me walk through this source. Here we have this API as we are using fast API. So that is for that one. This is like we are creating the app. We are using this fast API. It's health endpoint. This is our prediction endpoint. And then data. In this data, we have some pre-processing, generated the artifacts, loading the data, load hard disk data set, all the stuff here. This is feature, that is feature engineering we are doing here. This is our model. The main is trend.py. We are preparing our model, logistic regression and random forest, both model we are using. Yeah, so this is all walkthrough of our solution. Now let's proceed with our setup. Uh, it's already cloned, so that's fine. Now let's first of all let's create environment. So I'm using Python 3.11. So virtual environment is created. Let me activate it. Okay, it's activated. Now let's install these requirements. So all requirements are downloaded, done. Okay, now we'll use the download dataset. So we are executing this file. So this is our URL. So for downloading this data set, I think this is done, not yet. Okay, this saved rows. Now next is generate EDA artifacts. So we'll generate the EDA artifacts for our data set. If I go to this file, so this is our generate EDA artifacts. We are preparing histogram, feature histogram, then missing values, then class distribution, position, something like that. So if you come here again, you can see this generated figure will be saved in artifacts EDA. Artifacts EDA. Okay, it's already saved. Now next is feature engineering and model development. So we'll use this our main trend file, trend Python. So let me execute. So if you see here, the this train Python file, if I go there, so we'll use the pre-processing inside this only. We'll call pre-processing inside this only, and preparing training data, build processing pipeline, log, save model artifacts. So this is our main file, and we can call this file. We can execute this file. Okay, it's already copied. So now this command will train our logistic regression and the random forest, and then it also saved these evaluations artifacts under the same folder that this artifacts logistic regression, the random forest. See here, we are calling preparing training data, and if I go there, this is our preprocessor Python train our data. So we are using these all those pre-processing, cleaning, all those stuff. We are using the our train.py file only. Okay, now it's done. I think model training is done, and it's showing the both evaluation data for both the model logistic regression random forest accuracy at 8852, here at 8689, F1 is score, RACEC. So the train. It's done, right? Okay, now experiment tracking with ML flow. So we'll start ML flow locally. Okay, so let's do one thing. Maybe we can open a new terminal. That would be fine, I think. Okay, virtual environment. Now it's virtual environment. Fine. Let me run it again. Okay, this is done. Let's open this port 127.0.0.5.0.0. I think it's already there. Let me refresh it. Okay, here it is. Hard disk is MLOps training runs. Okay, here these training runs, random forest and the logistic regression. If I click on the random forest, here all the metrics, these are the parameters we used. This is log model, and here is the artifacts for this random forest, and this is model metrics, accuracy 0.87, CV accuracy, F1 mean, precision, recall. Same for logistic regression also. These are the metric data. These are the parameters. 8 9 is the accuracy. Here the artifacts for logistic regression. And so it's a ML flow, so we can do a lot of things from here. For example, if I want to compare these two model, I can do here only. So this is our model where all the run details is there, and we can compare the parameters, we can compare the matrices, accuracies. So it's 6 9 for in random forest, restriction 885. We will recall, yeah, and we can plot chart graph also. Okay, now let's come back to this one again. Let me open, this is running okay nowadays. So let me open this model package and reproducibility. So we are already saving the artifacts over here. So we can reproduce the same behavior again with the using these commands. So maybe I'm skipping right now this one, but this is for the reproducibility of the same model. Then this is for test. Test locally. Okay, all passed. Then this is our CI workflow. It's defined in CIML. So I'll show you that one also. Okay, so this is our CI workflow. All succeeded. And then containerization. Let me run this command. Allow. Okay, image is created. Let's check here. Hard disk API. Okay, now let's run this. It's running, right? Okay, here it is running. Let me execute call command. Okay, then again the prediction one. Okay, cool. We can check 127.0.0.80. Okay, Chrome also we can try. Okay, here it is. So we can call from Swagger also. Open API, yeah. And then stop when you're done testing. So we'll stop it later. First, we'll apply this Kubernetes. Either we can stop it and we can run it again, and we can apply Kubernetes deployment. So let me apply from here directly. But task 8. Okay, it's created. Okay, it's created. This is started. So deployment YAML file. If I open this YAML file, so this is our YAML file. Okay, 1000. Let me forward this port to 18,000. Okay, now verify. This is 18,000. So our Kubernetes deployment is running. We can show you here also. Okay, this is services running here. Let me verify the prediction endpoint as well. Okay, this is also copied, that's why no worries. So here the confidence is 0.814 and the prediction is 0, that is no disease. I have prepared one payload for prediction, positive prediction as well. So here the prediction is 1, that means yeah, R disease is there and the confidence is 98.55%. Now monitoring and logging, let's stop this one and we will apply this YAML file. Okay, this is stopped. Let's apply this YAML file. This is our docker compose YAML file. Where, here. Okay, 18,080 port, and for Prometheus we configure Prometheus as well, so here we are using 1990. Monitoring logging, yeah, here it is. So this is done. Let's verify. 18080. So here we got the Prometheus metrics data. uh, let's do one thing. From here also we can try from Chrome. So this is our metrics data. So we got this metrics data, and then we can call this one as well. So status succeeded. From here I think health endpoint or target. Okay, health is okay. Now let's open Prometheus. Okay, this is already done. Now Prometheus 1% 09090. Okay, status targets. This is up and running. So I believe this all done. Hmm. Healthy, unhealthy, and here we got the complete matrix from this matrix from this endpoint. For example, collection total generation 1, collection total counter. Okay, now this is quick verification checklist. Let's skip this one. As we already covered the complete setup. Now come back to the final report. Anyway, I already shared this final report, but showing you here. So these are my details, submission details, demo video. I'll attach this demo link here. Right now I'm recording this one. This is our CI/CD workflow. Then same problem statement, data set, then project overview, setup, installation, data set, then exploratory data analysis. You're saving here. Then these are the captured screenshots. I kept these screenshot here. Text continuous class distribution, feature correlation heat map. Let me close this one. Yeah, pre-processing feature engineering. We are using this pre-processing, which is model development. In the same model development, we are calling the pre-processing. Then these are our evaluation metrics: accuracy, precision, recall, F1 score, REC. See, so this is our major matrices data. Accuracy is more in logistic regression. Precision is also more weight recall and weighted F1. These are in logistic regression. This is REC curve and experimental tracking. We talk the model name, the hyperparameters, the matrices, confusion matrix. And we use ML flow with this command. And locally we can use this host and port. These are the captured screenshots. Then model packaging reproducibility. We are saving our models here. This is realized. So these are saved artifacts. So this ensure that API uses the same pre-processing logic that was used during the model training. Then API serving, we prepare these three endpoints. This is our main endpoint to predictions that returns prediction and the confidence of that prediction. So predictions are binary classification, whether 0 or 1. So 0 means it's no heart disease and 1 means there is a heart disease indication. These are the captured screenshots, containerization, images are there, attached. CI/CD pipeline. I attached the screenshots of that as well. Kubernetes deployment, screenshot attached for that as well. Monitoring logging. This is our logging. Then the architecture and the file submission checklist. So I make sure like whatever the cover mentioned here, that should be covered. So yeah, that all are covered. I think it's done from my side. Thank you.